Leetcode problem 853, car fleet. So let me first explain this problem. It might be a little bit difficult to understand. Yeah. So the problem is that at different places we're gonna have a car. So for example, one car gonna be at position 10, and another car gonna be at position 8. Yeah. And we are also giving a target. So for example, the target is 12. Yeah, so this is our target, and at each place of the car we're gonna have a speed. So for example, at the place of 10, it's gonna have a speed of 2, it's here, and at the place of 8, it's gonna have a speed of 4. Yeah, we just need to check if the two cars can meet with each other. If it can meet, so it's gonna become a car fleet. So this is just the idea. Yeah, so all the cars will drive at one direction. It will go to the right side. So for example, this car currently at position 10, it's gonna have a speed of 2, so it's gonna need 1 second to reach target, which is 12. So for this car, it's gonna need 1 second. So what about this car? So for this car at position 8, it's gonna have a speed of 4, so it's gonna need 1 second as well. So this means definitely at position 12, those two cars gonna meet. If they meet, basically it's gonna merge and it's gonna become a car fleet. So this means for this 10 and 8, it's gonna become a car fleet. So we're gonna count how many of them in total for all those positions. Yeah. Maybe currently it is still difficult to understand the problem. So what kind of solution we're gonna find to solve the problem? Because we are giving a position, and we are giving an add position, and we are giving a speed. So this means we can calculate the time at each position. So at each position we can calculate how many seconds we're gonna need to reach the target. Yeah. So for example, at position 10, so this means we're gonna need 1 second. At position 8, we're gonna need 1 second. Yeah. So what about position maybe 5? Yeah. So at position 5, so the speed gonna be 1, so it's gonna need 7 seconds. Yeah. So what about position 3? Yeah. So 12 minus 3, 9. So the speed is 3, so it's gonna need 3 seconds. So what about at position 0? So for example, this is a 0. So 12 minus 0, it is 12. 12 divided by 1, so it's gonna need 12 seconds. Yeah. So why this is important? Why we need to calculate the time? Yeah, for each of the car to reach the target. Yeah, because according to the time at different positions, definitely we can calculate if those two cars gonna merge with each other or not. So let's just use two examples. So at position 0, at position 3, yeah, let's just check two positions. Will those two cars meet with each other? So at position 0, the car is at the left side. At position 3, the car is at the right side. But for this 3, at position 3, it's gonna need 3 seconds. But at position 0, it's gonna need 12 seconds. This means at position 0, this car is slower. So if a car is slower, it can never meet with a car which is faster if it go to one direction, to the right side. Yeah. So now what do we have? We have such kind of time. So let me just clean up a little bit. We have the seconds at each position from 0 to 10. So we have 12, 3, 7, 1, and 1. So what left behind is, yeah, we just need to check how many cars gonna meet with each other, how many cars gonna become a fleet, and we're gonna need the time to check. Yeah. So this means from this side at the right side, so the time gonna always be more than the right side. Yeah, So for example, 12 gonna always more than 3. So this means those two cars will never meet before or after they reach the target 12. Yeah. So this means it's gonna become 2 fleet. So now it seems this problem is gonna become a monotonic decreasing stack problem. So for 12, 3, 7, 1, 1. So what's gonna be the monotonic decreasing stack? First of all, we're gonna put 12 inside of the stack, and then we're gonna put 3, and then we're gonna put 7. Because 7 is more than 3, so we're gonna pop out 3 and put 7 inside. So 1 is smaller than 7, we're gonna put it inside. 1 is more than or equal to 1, so we're gonna pop this one out and put another one inside. So how many values? 1, 2, 3. So we just need to return the length of the stack, which is gonna be 3. So this is exactly the monotonic decreasing stack. Yeah. So we're gonna turn the hard problem into a monotonic decreasing stack problem. So it's gonna become an easy problem. Yeah. So let's just use this kind of idea to solve the problem. We're gonna need a time. Yeah. So the time gonna be a mathematical calculation. So which gonna be the target minus the precision and divided by speed. So for precision and speed in a sorted zip of the precision and speed, because we need to check the precision from the left to the right side. So this is why from here we're gonna need a sorted array for the precision first and then the speed. Yeah. Now we're gonna need an empty stack, and we just need to use the template of the monotonic stack. Yeah. So we're gonna enumerate the time, and we're gonna check the stack, and we're gonna check the time if this t is more than and equal to something inside of the stack. Yeah. So let me think about it. It's gonna be the time with the stack minus 1. So we're gonna pop it out. So stack dot pop. So otherwise we're gonna put it inside. So stack gonna pad this value, this index, which is gonna be I. So finally, we just need to return the length of the stack. Yeah, so this is just a monotonic stack template problem. But before that, we needed to transform the precision and speed into time, and then we can solve it directly. Now let me just run it and submit it to check if it works. As you can see, it works and it's pretty fast, and the time complexity is dependent on this sorted array. This is n log n time. But for here, for the monotonic stack, this is O n time. So the final time complexity gonna be n log n. So n gonna be 10 to the power 5. Length of the precision array and the length of the speed array. I think that's about it. Thanks for watching. See you next time.